Okay, in this whole debate of Alfred Wegener, which went on for decades, there was an assumption. Scientists thought they knew it was at the bottom of the ocean, right? They just thought it was a flat earth, flat floor at the bottom. That's what they assumed. But, so they used to think the bottom of the ocean was flat, kind of like this, right? What evidence did they have for this? None. They had no way to see the bottom of the ocean. So they reasoned. They just made their hypothesis. The bottom of the ocean is relatively flat, right? There's nothing that exciting down there. Scientists now know that the bottom of the ocean is not flat at all. This is one of the major discoveries in geology that just sent scientists wild. Not only is it not flat, there are mountains down there. And that was shocking. Is this just another guess by scientists? Where's the evidence? This is where Marie Tharp comes into the story. After World War II, a new technology called sonar. They'd started to use this with submarines and things in the world in World War II. You basically are bouncing sound waves off the ocean floor. You're sending sound pulses into the water. They hit objects. This is what they were using to find submarines. Like the ocean floor, and bounce back. Scientists measure how long it takes for the echoes to return and how strong they are. Scientists can then create an image of the ocean floor. This is where Marie Tharp comes into the story. Reading and analyzing his measurements took a lot of time. That is what Marie Tharp did. She took data from the sonar and made it into maps. What she began to see was surprising. The bottom of the ocean was not flat at all. It had ridges and mountains. And that comes to the mid-ocean ridge, which is a key part to what Marie Tharp found and helped prove Alfred Wegener right. Okay. From these images, she started to see that there was a ridge. What's so controversial about this? What did it have to do with continental drift? So it's a deep valley in the ocean, right? With mountains on the side, right? So there's a deep, deep valley with high mountains like ridges on each side of the valley, making the valley. What is this? This implied the bottom of the ocean was growing and changing. They could see it, right? They could see that these ridges were getting higher. They're getting added to, right? Others, like Henry Hess and Jacques Cousteau, joined the debate. Their data confirmed what Marie's maps showed. The idea began to be known as seafloor spreading. Okay? That is, this valley in the mid-ocean ridge was getting bigger, and new land was coming up in between here. That's the idea of seafloor spreading, that these ridges were getting higher. What did they eventually realize? That this was magma coming up out of the ridge and piling up on the sides. The magma was like volcanoes, right? Underwater volcanoes coming up and dumping magma onto the edge and creating this deep ridge and high edges. Eventually, scientists came to call this moving Earth phenomena plate tectonics. Underneath the surface are giant plates that move on top of magma. Right? So these are the plates, not the continents, underneath the continents, underneath the land. Okay? Some plates, like the mid-ocean ridge, make new seafloor, called seafloor spreading. Some spread apart. They're divergent boundaries. They spread apart, and they make new floor. But here's the problem. What if there's always new Earth being made on the seafloor? Wouldn't the Earth just keep getting bigger and bigger and bigger? Well, no. Because at other places where these plate boundaries meet, some push together and one goes underneath the other, deep into the center of the Earth, and gets melted, like recycled. Okay? So here's the theory of plate tectonics. Yes, there are these mid-ocean ridges that show that the seafloor is spreading, getting bigger. But in other places, it's going underneath, diving down back into the magma, being reheated and recycled. That's the basic theory of plate tectonics that, again, took decades after Murray Tharp to really come up with. But that, finally, scientists had a mechanism, a way to explain how continental drift happened underneath the surface of these giant plates. Right? Some, like the mid-ocean ridge, which is evidence of continental drift. Right? It's showing, if the continents are on top of these big plates and these big plates are spreading apart in the ocean, that would cause the continents to move. That would cause South America and Africa to move apart. And that is eventually what led scientists to realize, this is the mechanism for continental drift. This is how the continents moved. Sorry, Alfred Wegener. You were right all along.